Welcome, everybody. I want to talk to you about creating a moving platform, and this is what we're going to work on today. Oh, except for if you can't actually hit the button, then nothing happens. But this is what we're going to work on today. Oh, look at that. Moving platforms. Yes, that's right. Moving platforms. So in order to do moving platforms, we're gonna work with some pretty interesting concepts. We're going to use mathf.smoothstep and a thing called coroutines, and also one of my favorite words to say, Lerp. Yes, we're going to use vector3.lerp to get all of these working. So what we're going to do is we'll begin by assembling our objects, and then we'll talk about the concepts and the code. We're going to test it out, and then I want to finally end with showing you configurations for all the cool things we can do with this button platform prefab. But before I do, let me go back to the last version of code we had before I added this, so that you can see how you can add the prefab of button platform and get that working. Okay, we're back to where we were in the last tutorial. I'm going to move my player up here. I'm going to put it right above here where we can grab the button platform prefab. I just want to remind you they're all listed in the provided folder. And so this is something we downloaded in the very first video. So if you didn't get that, you're going to need to get it. Go back to the first video, find the link to it. First thing we want to do is go into the prefabs under provided. See where it says button platform? That's the button platform. And what we want to do is drag it into the prefabs folder with the capital P directly inside of assets, like you see assets, prefabs, right? So now we go to prefabs, and now you can see the button platform. And the other thing we're going to do is move some scripts. So we're going to go to scripts, and we're going to deal with the button controller. I'm going to drag that into scripts. So you want to make sure button controller goes into scripts. And then we're going to do the same thing for utility. One of the things I hope you're noticing here is that this list of scripts is getting smaller and smaller. That means we're getting closer to the end of this tutorial. All right, so we're going to use the utility script, and we're going to use the button controller. But before we do, let's grab the button controller and drop it into our scene. So I go back to prefab over here, drag it out, and we're going to stick it right under there. And then we're going to test some things. Let me get this pickup out of the way. We'll move that down there. All right, and now that we have the button platform, I just want to walk through what's in here. There are three components that make up this one object. One is the button, and let's zoom in on here. So the button has a collider with it. The script is attached to the button because it's the button that creates the action. The button is embedded in the base, and then to the right of it is the platform. And you can actually configure this where you can move the platform to different locations. One of the things we're going to do is we're going to talk about what can you do with it. The first thing I want to show you is the button controller, and I want you to see all of these elements we have here. We have platform movement, platform scaling. We also have transformation time, and we're going to get into that in more detail. Let's just do it now, just so you kind of have an idea as to what's going on. Transformation time is how long we want the animation to last. Okay, so in this case, it's 2 seconds. So for 2 seconds, it's going to do the following. It's going to move. Now, X is 0, so right now it's designed to just not move left or right. And then it has a Y of -8. That's going to drop it down. And one of the things I noticed is we have this platform right here. I'm going to move this out of the way so you can have a better idea of what's going on. In fact, I'm going to scroll down out a little bit. I'm going to move this out of the way too. Take this platform, get it out of the way. Because this thing is going to drop down by 8, and it could be a significant amount all the way down to here. All right, so we keep that in mind. Now, the cool thing about this button controller is that not only can we move it up or down, if we want to move it up, we just give it a positive number. If we want to move it down, it's a negative. If you want to move it to the left, give it a -X. If you want to move to the right, give it a positive X. Forward or backward, but we're leaving Z at 0. This is movement. It's called transform when you move an object into a new location. We can make it go diagonally by giving it an X and a Y. So we can have all kinds of interesting movement. And then scaling is its size. So a 1 represents 100%. So it's 100% the standard X scale size, which in here is technically not the button, but the platform is set to an X of 1 and 1. So this width we have here, no, I'm sorry, it's the platform here. Sorry, it has a scale of 4. Okay, so we give it a value of 4 compared to the 8, which is what these platforms are. But that's the scale of it. If it was 1 by 1, it would just be a cube, right? Okay, go back to the button platform. Here are all the information we can use. But let's talk about the script. So we're going to take a look at the button controller script first. And you are going to have to do a little edit to this code. We don't want to just give you everything for free. But the first thing you're going to see in the button controller is all this how-to stuff. All right, the first disclaimer I have to make is understand that this how-to is not about adjusting the code inside. I was scratching my head for a while when I first saw this tutorial. It was written, I was looking at it, I had no idea, like, how am I going to code all this? Turns out this is more about how you configure it later. So we're going to come back to that later, but we're going to jump down a little bit. Notice this is the button, and we have a trigger collider. So when the player collides with the trigger, we're going to check two things. One, the other will be the player. And then, so we're going to check the game object. We're going to check if it has a tag, if the player tag matches. In this case, it's going to be player. If that matches, that's the first thing we're checking for. But we're also checking to make sure it's not activated. All right, what's activated? Well, activated in this case is a private variable. It's a Boolean, which means it's true or false. And it's set initially to false. We're saying that the button is not activated. In other words, the button is off. It's like it's in the off position. So the first thing that happens is we're going to compare it. And the first time we collide, both will be true. The other tag will have the player tag that will match, and it's not activated because it's false. But look at the first thing we do if that's the case. First thing we do is this thing called log, and I'll show you where that shows up because it's definitely worth looking at, especially if things don't work right. We use that for debugging, which is why it's part of debug. That's built into Unity, so don't worry about that right now. But we're going to say button pressed moving platform, and it's actually going to indicate the name of the platform that is moving. Now we set activated to true. That basically now says the button has been activated. So if we collide with the button again, it's not going to do this anymore. It's going to ignore that. And on the trigger enter, it'll do nothing. Okay. So we have to wait till it's no longer activated. Once it's activated, it's never going to get set back to false unless we have somewhere else that we deal with it. But we don't for now, so we're just going to leave it alone. All right. Then we have this move object, scale object, move object. So the question is, where can we find these methods of move object, scale object, move object? Okay. Well, here's scale object. Go a little bit further down, there's move object. Now, scale object has been done for you. Okay, and it scales it. And the move object has not been done for you. Now, we're going to come back to this because I think it's better to deal with utility first. And then we'll come back here and code it. So let's leave this alone for now. And let's go straight to utility. And I know this is a lot of content. We're hitting a lot. And let's go ahead and open it up. I'm going to move this off to the side. All right, now we have a to-do list, okay? This, by the way, is a utility class. It's not attached to any object. It's a thing that makes it useful, right? It's something that we can use in our game. We put it into the game by dropping it in scripts, and we make it public, which means anything can call up utility. So this is actually a script designed for other scripts, okay? And let's close this so we can see all the things it does. That basically utility can move over seconds, scale over seconds. Let's look at scale over seconds to see what it does. We have a game object, that's the object, and that's what we're moving. The end is going to be its end position. Now we can get its current position, but we don't know where the end position is supposed to be. So when we call scale over seconds, we have to tell it where it's going to end. And the last thing, it's going to choose seconds. Now, the comment here says it's a coroutine for scaling a game object, and that looks wrong. Let's fix that spelling. Here, I feel much happier. And over some amount of seconds. Now, so let's talk about what a coroutine is. So I've pulled up the Unity manual and I just Googled Unity coroutines and I've got it. I'm going to give you the answer for it just for you to know. Let's say we want an object to fade into nothingness. We want it to fade away and we call this function called fade. It's going to loop over time and over basically over 1 second, it's going to fade away 10% at a time. Here's the problem. If we were to do this in, let's say, update or late update or whatever, if we were to do that inside of there, it would actually loop and do all this stuff and only output what happens after the loop. So at the end of the loop, you're going to be at an opacity of 0, which means it'll go directly from visible to invisible in the span of 1 frame only. So what we need is a way to sort of have it work over time. And as time goes by, it gradually decreases. So we do this thing called a coroutine. It has a thing called an I numerator. A numerator is basically going to allow you to loop, and then every time it gets to this yield, it's going to send information out into the update that called it and pause and wait. Okay, and if you notice here, update, it says if input get key down F, it says start coroutine. Once we start it in update, this will continue in update until we're done looping. So basically, this will loop 10 times, and it will loop 10 times over the course of 10 updates, which will give it a fading away effect. Well, we want to do the same thing with movement. We don't want it to immediately go to a new location. If we did, we could just set the time to 0. But we want to make it so that we can have it animate slow, animate fast. We can adjust it. So for that reason, we create a coroutine. So that's what the coroutine is. Now, let's take a look at the scale over seconds, because this is all coded for you. There's nothing you have to do in here, but it's a great way to look and see how does this scale over seconds. We need 3 pieces of information. We need to know the object, the end position, and the time, which I've already mentioned that, right? Now, a vector 3, what's really cool about a vector 3 is a vector 3 could give you position, but it also can give you a scale. So this basically works with transforms, right? So you'll notice we start with an elapsed time of 0 because when we first start scale over seconds and we start that coroutine, no time has elapsed. Then we create this trans, we call it trans for transform, and we set it to obj.transform. So we create a variable that's set to the position of the object where it begins. And then we do this thing called starting scale, and we call local scale, which basically grabs what the current scale or size is. We set it to starting scale, and so we go into elapsed time. So elapsed time starts at 0. Let's say it's going to count up to 2, and it's going to go over the course of a bunch of updates. Elapsed time starts at 0. 0 is less than seconds, which is we're going to set to 2, let's say. And then we do this trans.locate local scale equals vector 3 lerp. Now, lerp, that's the other thing I said we're going to get to. We haven't even done any coding, but let's talk about lerp. Lerp is fun to say. And if you do, just make sure you clean it up. You might want to get your lerp checked. I don't know. Who knows? I don't know what it means, but it does sound like it's something we shouldn't talk about in public. But that's not the case. We can talk about a lerp. And a lerp, a fancy word, says interpolates between the vectors A and B by the interpolant T. Oh, doesn't that just make sense, right? Modern day English, right? No. Actually, to interpolate means you're kind of interpreting, and you're kind of trying to decide where are we at any given time. So let's say we have a transform that's a start marker and we have an end marker. And then we have the movement and speed units per second. We set speed to 1. And then we have a start time, okay? And then we have the journey length, which is how far we want to go between the markers. We do a start. We do this update. Let's see. I think it's probably better to do it this way. Well, let's just talk about what it is. I'm sorry. Let's talk about what it receives and what it gets. It receives a vector3 start position. It has an end position. So we have two locations in space. We have time. All right, the time is going to be the elapsed time, or the fraction of time. What percentage of time are we at currently? So if we know the start position and the end position, all we need is now the time. Once we have the time, we know exactly where we are. If we are in a 2-second lerp, and let's say we're going to go basically 2 clicks. That should be 1 click each second. If 1 second has transpired, we will have moved 1 click over, because 2 divided by 1 equals 1. That's how far we need to go. Once we know how far we need to go, we can get our XY position. It's just a linear line from A to B, and wherever we are plotted at that whatever fraction, there we are. So it's actually not terribly difficult. And the Lerp, again, it's linear, because that's a line I mentioned, interpolates Lerp. That's where it comes from. Linear interpolate. So we run it, and it asks for these information. I'm going to break this out so you can see it. We have start, scale, end, and then smooth step. Now, what's the scale about is that's the size, remember? So beginning size, end size, okay, that's how big it needs to be at the end. And then we have this thing called SmoothStep. And all SmoothStep does is it figures out where it needs to be, and it kind of smooths it out. This just allows your animation to go a little smoother. Okay, let's not get into too much detail. We're already way into this video. But notice the SmoothStep, we give it beginning, end, and then we have the elapsed time divided by seconds. I'm sorry, 0, 1, elapsed time divided by seconds. Then we sync up, we add time.delta time. We add how much time has changed from the last update to this update, and we add it to elapsed time. And then we send this value out, and it sends it. And then it waits for the next time it gets called. When it gets called again, it goes back up here. It compares the elapsed time. If it's still less than seconds, we do this again, and we keep doing it. We keep sending out information every frame until it's finally done. And then we have this local scale, vector 3, blah, blah, blah. Okay. I don't even remember why we're doing it, but I'm like, oh, let's code. Let's get this coded. All right, so we're going to take this here. We have, over here, we have a to-do list. We need to move our position to some Lerp vector between starting position and end based on something which I can't see because I need to zoom out. It's based on the elapsed time. Okay, first thing it says over here, to do, remove this line and uncomment the 2 lines below. The first thing I want you to do is delete, backspace, and I want you to delete the comments over here and over here. So the only thing we have to really do is fix this error. We need to give it 3 positions. Now, here's what I am going to suggest we do. I suggest you pause this video and you see if you can get the Lerp to work correctly. Okay, so you need to figure out what you're going to send. I'll give you some hints. Hint number 1, hover over the Lerp, the word Lerp, and you should see vector A3, or vector 3A, vector 3B, float T, and you can even read what that means, right? And you can even look at potential fixes. I don't know if that will help you or not, but you can do that, okay? The other thing you can do is look at our other Lerp, vector 3 Lerp, down here, which I broke out to sort of give you an idea. So between this information and hovering over here, you should know what to do. But if you don't worry. I will give you the solution in just a moment. The next thing I would like you to do after you pause, because you're going to need to test it out to know if you got it right or not, I want you to go to button controller, and I want you to fix this to do 411. Call our move over seconds coroutine. So what you're going to do is uncomment that line, and then I want you to refer to line 57 to see how scale object work by starting a coroutine. So this gives you some ideas to what you need to do. But understand, we're moving an object here. We're not scaling an object there. So we're not going to scale over seconds, right? Because we already did that there. We need to move, okay? So what I want you to do here is to delete that and start coding through here. And then pause the video, see if you can get both of those done, and then come back and I will give you the solution. Okay, I hope sufficient time has passed. We're going to go to vector 3 lerp, and we're going to hover, and we're going to see the first thing is A, which is the start position. And if you look here, game object, obj, starting position is set here. We even have it down there. Oh my goodness. Copy that, Roger. Put it in here. Add a comma. Next, we need the end position, where we're heading towards. That's this vector 3 end. That wasn't so bad. Comma. Finally, what are we going to do? We need to take a look down here, and our last lerp is this mathf.smoothstep. We're actually going to do exactly that same piece of code. That's mathf smoothstep. Sounds like a song. I think it was Michael Jackson who did that song, SmoothStep. Yeah, I'm not sure. Anyway, all right, the point is that should work. Save your changes. Go over to the button controller, start coroutine. Let's take a look at it. Utility is where we get it from. Use your IntelliSense. Use TUT. See how utility is already highlighted? Hit enter. Add a dot. See what you have available. Hey, look, there's one called move over seconds. Hey, look, up here it's private void move object. Maybe that's what we need to do. Yes. And then move over seconds. You'll see scalar seconds has this parenthesis because it's a method. In our method, we need an object, an end, and seconds. Oh, look, move object, obj, comma, end. Look, vector 3 end, comma, seconds. All right, what did we do on our other one? Delay seconds. Do we have a delay seconds? Yes, we do. Delay seconds. Save your changes. Go back. Test it out. Wait for it. Hit play. All compiler errors. Auto-saving assets before entering play mode. I have a compile error. Where? Over here. It's red. I hover. It says parenthesis expected. I should have remembered. I needed another parenthesis because utility move over seconds is its own method. So it should begin and end with a parenthesis, right? All right, now I'm going to go back to where it was before. Let's save our changes. Let's see if it now works. And then it's going to collide with the button, and we're going to see. There it is. And it worked. All right. Wow, that thing is moving fast. I'm going to make a quick little change to the lib box. We're going to change it y of -1. All right, slow that sucker down. All right, so now you got the you've got the platformer working, right? All right, let's make some adjustments to it. All right, what if we don't want it to move down? Double click, go to the button where it says platform movement, change the y from -8 to +8. Oh, we said what if we don't want it to go down? Set it to 0. Set an x of 2. Run it again. It should move to the right by 2. Sure enough, over 2 seconds. There we have it. All right, let's say we want to move to the left. We have a problem. Our platform is on the right-hand side. So if we try to do that right here and change that to -2, let's see if it even works. Maybe it does. We're going to find out in a moment, won't we? -2. Let's try it. Player falls, hits the button, and it does move to the left. Well, that's kind of cool. All right, I like that. But you might want to give it extra values because you do have that little button there. So now about -4. And then we play it. What if we want it to go diagonal? Look at that. That's cool. Because of the friction, it actually rolls it. Okay, that's pretty cool. So there's all endless possibilities. Oh, let's go diagonally. Let's run it now. Now it'll be really cool. Watch what it does to our poor player. Look at that. That is so awesome. Okay. What else can we do? Scaling. All right. What if we set this to 0? Now what happens? Oh, just disappears. Is that cool or what? You can have it disappear by changing its x to 0. We could change its y to 0. We could change both of it to 0. We could make this happen really fast. We could give it like 0.5 and just endless possibilities. Play around with the scaling, play around with the movement. And here's the beauty of this all, right? We've been editing our button controller, clicking on button right here in the scene. If I grab another prefab button platform over here, I could have it do something else, right? I can move this over here, get this out of the way, and we can do chain reactions. We could do all kinds of stuff. So I go over here, click the button. I want to keep the X at a 1 and the Y at a 1. And then that'll take us to the other one, hopefully. And let's give it a -5. And we run it. And let's see what happens. Oh, it kicks you off. So you could do all kinds of fun stuff with this. I hope you have a lot of fun. In fact, I would recommend after watching this video that you just take a scene, maybe create a new scene and have it nothing but different platforms. Some send you the right way, some send you the wrong way. All of them eventually, maybe if you set it right, will, if you get the right ones, it'll lead you to this finished platform. Figure out what other options you have available. Mess with different stuff. See what you can do. Have fun. And when you're ready to come back for the next video, maybe it'll already be waiting for you. So take care. Thank you for watching.